Hi guys, welcome back to week 3. Last week we talked about mapping the earth and longitude and latitude, and I thought today we would take a little break and learn about rocks and minerals. So to be a mineral, it has to be naturally occurring and made from non-living things. So fossils and coal are made from living things that died, so they're not considered minerals. And minerals can't be man-made. So minerals must be a solid, they have to have a fixed shape and volume, and they're never living or inorganic. So minerals must have a definite crystal structure. Particles line up in a regular repeating pattern. Flat sides, called faces, meet at sharp edges and corners. So all of these shapes over here are different types of crystals. So minerals must also have a definite chemical composition, so they always contain certain elements in the same proportion. Almost all minerals are compounds, which means that they have two or more different elements chemically joined together. So, to review, minerals must occur naturally in nature. They have to be an inorganic solid. They must have a crystal structure, and they must have definite chemical composition. So some properties of minerals are hardness, that's how you're going to measure how easily a mineral can be scratched. So if you look at the picture here, this person is using a nail to scratch the mineral to see if anything comes off of it. Density is another property of minerals. Minerals will have a certain density regardless of the size or shape of the sample, okay? So each mineral has its own density called specific gravity. Luster. This is the way the mineral reflects light. It can be metallic, so shiny, or non-metallic. It can be shiny or dull. It can be waxy or pearly or glass. This is a gemstone called tourmaline, and it has a glassy luster. Streak. So this is the color of its powder, not always the same color as the mineral. So if you look up here, this is hematite, okay? And when you're holding it, looking at it, it looks dark brown or sometimes black, but when it's scraped against this, it makes a reddish brown streak. And color. That's the first thing you notice about minerals. So now let's talk about rocks. So rock classifications are texture, grain, minerals, color, and origin of rocks. So texture is how a rock looks and feels. And texture in rocks is determined by the size, shape, and pattern of a rock's grains. So the grain is the size, it could either be large or small. The shape, smooth, rough, or round and jagged. And a pattern, so it can have rows or waves or swirls or beads or just random patterns. So mineral composition is the fact that rocks are made up of more than one mineral. So let's talk about some other rock classifications. How about colors? So colors are another thing that you notice right away about rocks, right? And they come in all sorts of colors. So, origin of rocks. How were they formed? Were they formed with magma, erosion and layering, or heat and pressure? So, igneous rocks are formed from the cooling of magma or lava. So, lava is magma that reaches the Earth's surface. Okay, so here we have some lava, okay, and it creeps up here like this, and oh goodness, it's going to come out of this volcano. Now it's magma, and it's reached the Earth's surface, and it's going to cool off, and it's going to form igneous rocks. Sedimentary rocks are formed from other rocks that are broken into small particles and moved by erosion, which is wind or water. So the particles are squeezed or cemented together and the rocks are layered. Okay, so here's layers of sediment. And they form when materials like sand and like the remains of living things, they settle on the ocean floor and then they get smushed together and all that pressure creates rocks. And then we have metamorphic rocks, and they are formed from other rocks. So rocks that have been pushed deep, deep into the Earth's crust, either pushing down on this ocean floor, right? Push, 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 and then it gets sucked into this middle, and then the middle is really hot and there's lots of pressure, right? So it's pushing back this way, and when you're putting all that pressure together, it'll make a rock outside of another rock. So pressure from the earth above and heat from the mantle below cause them to change shape, color, grain, and crystal structure, because remember, pressure and heat can change the structure of a crystal. So here we have the rock cycle. So we have igneous rock, sedimentary rock, and metamorphic rock. Now if you look at the green arrows, they talk about weathering and erosion. Now all rocks, regardless of its type, with weathering and erosion create sediments, which are just like little pieces, okay? So when those sediments get compacted, they turn into a sedimentary rock. Now when the sedimentary rock heats up and it has pressure, it turns into a metamorphic rock. And then this metamorphic rock is going to melt and then cool and turn into an igneous rock, okay? So this is the rock cycle. So that's all we're going to talk about today with the rock cycle. Wanted to keep it super easy. Like I said, welcome back to week 3, and I am excited to see you in the meeting today.